If you've been enjoying these space stories, tap like and subscribe so you don't miss the next one, and drop a comment telling me where you're listening from tonight. Your city, your state, even just in bed is fine. Now dim your room a little more, let your shoulders unclench, and settle in, because tonight we're drifting into Saturn. Saturn is the kind of planet that feels like it shouldn't be real, like someone designed it on purpose, because no other world wears its beauty so openly. From far away, Saturn is instantly recognizable, that warm, pale gold globe and the rings slicing through space like a clean signature. But the more you learn, the more Saturn stops being the pretty planet and becomes something deeper, a massive world of storms and pressure and hidden heat, a planet made mostly of gas that still behaves like it has structure and personality, and a ring system that's not just decoration, but a living, changing place made of countless pieces. If Jupiter feels like raw power, Saturn feels like power-wearing elegance, and that combination makes it perfect for a sleep story because it's both grand and strangely gentle to imagine. Start with the first calm thought. Saturn is huge, but it's light for its size. If you could somehow place Saturn in a bathtub large enough, it would float, because its average density is lower than water. That fact sounds like a gimmick until you sit with what it implies. Saturn is mostly hydrogen and helium, a world without a solid surface, a planet that is more like a deep atmosphere than a place. And yet it doesn't feel like a cloud. It feels like a structured world because gravity organizes everything. Saturn spins fast, about 10.5 hours for one rotation, so fast that it bulges at the equator and flattens at the poles. It isn't a perfect sphere, it's stretched, like the planet is still responding to its own rotation. That rapid spin also helps shape Saturn's weather into bands and jets, like flowing rivers wrapped around a globe. When you look at Saturn through a telescope, you can sometimes see the subtle stripes and storms in the atmosphere, but they're softer than Jupiter's high contrast patterns. Saturn's palette is creamy, honey-colored, more muted, like the planet is covered in thin haze that blends the edges. That haze is part of why Saturn looks so smooth and calm from a distance. But calm is another one of those lies your eyes tell you. Saturn has winds that can reach incredible speeds, and it can produce storms that grow into planet-spanning events. Saturn is a world where the violence is real, but the visuals are soft, and that contrast is one of its most hypnotic features. Imagine hovering above the top of Saturn's cloud deck. There's no ground, only layers, clouds made from different compounds depending on depth. Ammonia ice clouds higher up, and deeper layers where other chemicals condense as temperature and pressure change. Light from the sun is weaker than on Earth, but still strong enough to paint the clouds with gold and beige and pale gray. And beneath that beauty is motion. Winds slicing past each other, bands moving at different speeds, clouds forming and dissolving. On Earth, weather feels local. On Saturn, weather can be the size of continents, and the planet doesn't care. It spins, and the atmosphere rearranges itself around that spin like fabric around a rotating sphere. One of the most famous Saturn features is the hexagon at the North Pole, a six-sided jet stream pattern that looks almost impossible, like a shape you'd draw with a ruler. But it's real, and it's been observed for years. That's Saturn in a nutshell. Physics producing something that looks designed. A hexagon made of wind, a polygon made of atmosphere. It's not a trick, it's a stable pattern created by the dynamics of a jet stream in a rotating fluid. When you imagine it, don't imagine a solid outline, carved into the planet. Imagine a flowing current that happens to lock into a geometric rhythm, the way a wave can organize itself in a repeating pattern if the conditions are right. Saturn's polar regions are a different kind of world than its equator. Different sunlight angles, different circulation, different clouds. Yet it all connects, all part of one rotating system. And then there's the deeper Saturn, the part you never see, but that makes the planet what it is. Go down beneath the visible clouds, and pressure rises fast. Hydrogen stops behaving like a light gas and becomes denser, warmer, more fluid-like. Deeper still, under enough pressure, hydrogen can become metallic, behaving like an electrical conductor. That metallic hydrogen is one reason giant planets can generate strong magnetic fields. Saturn has a magnetic field too, and it's unusually aligned compared to some other planets, which makes it feel stable and centered. But Saturn's magnetic environment still shapes space around it, trapping particles, guiding them, interacting with the rings and moons, creating auroras near the poles. Faint glows in Saturn's upper atmosphere where charged particles crash into gas and release light. The space around Saturn is not empty. It's structured by fields and particles and gravity. It's a whole environment. Saturn also gives off more heat than it receives from the Sun, meaning it's still releasing energy from inside. One explanation involves helium rain. In Saturn's deep interior, helium can separate from hydrogen under certain conditions and form droplets that sink deeper, releasing gravitational energy as heat, like a slow internal drizzle that powers the planet's warmth. That image is insane in the calmest way. A planet where helium literally rains downward inside, feeding the heat that drives weather above. Saturn's beauty isn't surface level. It's powered from within by physics you can't see. But if Saturn were only the planet itself, it would still be fascinating. The rings are what turn it into a dream. Saturn's rings are made of countless particles, mostly water ice, ranging from tiny grains to chunks as large as buildings. They orbit Saturn in a thin plane, each particle following its own path, and from far away it looks like a smooth, solid structure because there are so many pieces packed together. The rings are bright because ice reflects sunlight well. And the rings are not one single ring. They're a system of many rings and gaps, divisions and waves, patterns created by gravity and resonance. Moons tug on ring particles and sculpt sharp edges. Some moons act like shepherds, maintaining narrow ringlets. Some create gaps by clearing out material. Some stir waves through the rings, ripples that can be seen as spiraling density patterns. The rings are like a record of gravity in motion, visible mathematics. If you want one calming way to picture Saturn's rings, imagine them as a massive frozen disk of glittering ice shards, all orbiting in silence, each one turning and tumbling, catching sunlight in tiny flashes. No sound, only motion. And because the ring plane is so thin compared to its width, it feels impossibly delicate, like a sheet of light. But it isn't fragile in the way you think. It's dynamic. It's changing. Ring particles collide, grind down, clump together, get pulled into waves, get nudged by moons, and slowly evolve over time. Saturn's rings are not static jewelry. They're a living system that constantly reorganizes itself. That makes Saturn's whole vibe different from other planets. You're not just looking at a world, you're looking at the world's surrounding structure, an entire orbital ecosystem made visible. Then come the moons, because Saturn's moons are not background objects, they're worlds. Titan, the biggest, is a moon with a thick atmosphere, thicker than Earth's in some ways, hazy, orange, hiding lakes and seas of liquid methane and ethane on its surface. Titan is one of the most Earth-like places in the solar system in terms of having weather and rivers and lakes, but with the chemistry swapped, an alien version of the water cycle, where hydrocarbons play the role of rain. And then there's Enceladus, small but stunning, shooting plumes of water ice and vapor from cracks near its south pole, evidence of a subsurface ocean beneath its icy crust. Those plumes feed Saturn's E-ring, tying the moon directly into the ring system like a fountain feeding a halo. Saturn's moons make the system feel alive in a way that goes beyond the planet itself. Not just gas and ice and gravity, but active geology, hidden oceans, thick atmospheres, and chemistry happening right now. Saturn isn't one world. It's a whole neighborhood of worlds, all tied together by the same gravity. And gravity is the quiet main character of the Saturn story. It's what shapes the rings into sharp edges and gaps. It's what locks moons into resonances. It's what organizes storms into bands. It's what compresses hydrogen into strange states inside the planet. Gravity is the reason Saturn can be both soft-looking and unimaginably powerful. The planet doesn't need mountains or continents to feel real. It has mass and rotation and layers, and that's enough to create structure. And that's why Saturn is so soothing to imagine. It's enormous complexity made orderly, chaos made into patterns, a storm becoming a hexagon, ice shards becoming a ring, moons shaping gaps with invisible tugs, internal helium separating and falling like rain, everything moving, nothing making noise. So for this first part, the goal is simple. Lock in the feeling of Saturn before we go deeper in later parts. Saturn as a pale gold giant spinning fast, slightly flattened by rotation, covered in soft bands and hazes, occasionally building storms big enough to wrap around the planet. Saturn as a world with internal heat, possibly fueled by helium falling deeper inside. Saturn as a magnetic environment with auroras flickering near the poles. And Saturn as the ringed planet, not because the rings are an accessory, but because they're an entire system of ice and motion, bright, thin, structured, alive, surrounding a giant that doesn't have a surface yet, still feels like one of the most solid presences in the solar system. In the next part, we'll sink into the rings themselves, how they're organized, why there are gaps, what resonances do, and how moons carve patterns through a disk of ice until it looks like art. Saturn's rings are the cleanest proof that gravity can make art without trying, because what looks like a single perfect halo is actually a sprawling, constantly shifting disk made of countless separate pieces, each one orbiting Saturn on its own path, colliding, clumping, grinding down, and getting sculpted by moons into sharp edges, gaps, ripples, and waves that stretch for tens of thousands of miles, yet remain unbelievably thin compared to their width. If you could float above the ring plane and look sideways, you'd realize the whole structure is more like a razor-thin sheet of moving ice than a thick band, because the main rings are only on the order of tens of meters thick in many places. Sometimes a little more, sometimes less. So thin that it almost feels illegal for something that wide to exist without tearing apart. But it holds because each particle is doing the simplest thing in the universe. Falling forever around Saturn, the rings are mostly water ice, which is why they're bright, and the brightness isn't uniform because the rings aren't uniform. Saturn's ring system is organized into major regions and substructures that look like they were designed with deliberate spacing, even though the spacing is just physics, primarily orbital resonances and gravitational shepherding. You'll hear names like the A ring, B ring, and C ring, and those labels make it sound neat, but the reality is more like a spectrum of density and texture. The B ring is the most massive and opaque, packed with ice chunks and clumps so dense it can block sunlight like a wall from some angles, while the A ring is less dense but still bright and sharply structured, and the C ring is more translucent, dustier, allowing more light through, like a thinner veil closer to the planet. Between the A and B rings sits the Cassini division, the famous dark gap that looks empty from far away. But it isn't truly empty. It's a region with less material and different structure, still containing ring particles and ringlets, just not enough to reflect sunlight the way the densest rings do. And the reason the Cassini division exists is one of the most satisfying Saturn stories, because it's the purest example of resonance carving. One of Saturn's moons, Mimas, tugs on ring particles in a 2.1 orbital resonance, meaning particles there would orbit Saturn twice for every one orbit of Mimas, and that repeating gravitational nudge over long time destabilizes or reorganizes particle orbits, clearing or thinning material into a gap and pushing it into wave patterns, like a drummer tapping the same beat until the whole crowd moves. This is the ring system's secret. It isn't static matter sitting still, it's matter being continuously sorted by repeated gravitational rhythms, and those rhythms create patterns you can literally see, because Saturn's rings are full of spiral density waves, ripples in particle density that wind around the planet, like grooves on a record, generated when moons tug on ring material at specific resonance locations. If you could hover above and watch long enough, the waves would look like slow-motion spirals tightening and spreading, each ridge a place where particles bunch slightly closer, each trough a place they spread slightly apart. And none of it needs a solid surface or a builder, only the combination of Saturn's gravity, the moon's periodic pulls, and the ring's constant collisions that turn orbital energy into heat and keep particles from drifting into chaos. Inside the A-ring you find smaller, sharper gaps that feel like fine detail etched into the disk, like the Encke gap and the Keeler gap. And those aren't just empty cuts either. They're maintained by tiny moons orbiting within them, like Pan in the Encke gap and Daphnis in the Keeler gap. And these moons are almost unfairly perfect because they act like little plows, clearing lanes as they orbit while also generating edge, waves along the gap boundaries. When Daphnis passes, its gravity lifts and drags nearby ring particles, creating scalloped vertical ripples that look like the ring edge is being pinched and ruffled. And that's when you remember the rings have height, however small, and that they can be bent, not just compressed. Those bending waves and vertical structures become even more dramatic in places where the ring plane is forced to tilt or warp by resonances. And the Cassini spacecraft saw these structures in detail, revealing that the rings are not a smooth, flat disk, but a textured landscape of ridges, wakes, and wave trains, like a frozen ocean with patterns carved into it by invisible tides. One of the most hypnotic details is that ring particles don't just spread evenly. They form self-gravity wakes, elongated clumps that arise because the particle's own gravity lets them temporarily gather into streaks, while collisions keep them from collapsing into one big body. So, the ring becomes a constantly forming and dissolving pattern of narrow, dense strands, like a school of fish that's always reorganizing. And those wakes change how the rings reflect light, which is why the rings can look different depending on viewing angle and sun angle. And then there are propellers, which are disturbances caused by unseen moonlets embedded within the rings, too small to be easily imaged directly, but large enough to shove ring particles aside and create a propeller-shaped gap pattern that can persist and drift, like a signature left by a hidden object. Saturn's rings are full of these half-visible clues. You don't always see the cause, but you see the shape it carves, and in a way the rings teach you how to read gravity like handwriting. The moons outside the main rings also shape them from afar, especially the shepherd moons that guard narrow rings or ring edges, like Prometheus and Pandora sculpting the thin F-ring, which is one of the strangest parts of the whole system because it looks like a single ring until you realize it's a braided, kinked, clumpy ribbon that's constantly being stretched, knotted, and reshaped, with mini-jets, strands, and clumps forming as the shepherd moons tug at it on each pass, sometimes pulling streamers of material out like threads, then letting them fall back and twist, so the F-ring behaves less like jewelry and more like a living rope being flicked and combed in slow motion. The F-ring is also a reminder that the rings and moons are not separate categories. Some moons feed rings, some moons clear rings, some moons live inside rings, and ring particles can clump into temporary moonlets that later break apart, meaning the boundary between ring and moon is a sliding scale. In Saturn's system, you can almost watch that scale in action, because collisions grind big chunks down into smaller ones, while gentle sticking and self-gravity can build clumps back up, a constant contest between construction and erosion. This leads to one of the biggest Saturn ring questions that still hangs in the air. How old are the rings, really, and where did they come from? One story says the rings could be relatively young by solar system standards, maybe formed from the breakup of an icy moon or a captured body that wandered too close and got torn apart by Saturn's tides, leaving behind a disk of icy debris that spread into the current ring system. Another story says the rings could be much older, perhaps formed early and then continually renewed, with ice kept bright by processes that clean or replenish it. The reason this question exists at all is that over long time the rings should get dirty, because micrometeoroids and dust falling in from space should pepper the ice with darker material, gradually reducing brightness. And yet the rings are very bright, which makes them look young. But brightness alone can mislead, because it depends on how material is mixed, how frequently surfaces are resurfaced by collisions, and how much dark material is actually there. Cassini data complicated the picture by measuring mass more precisely and by observing interactions between rings and Saturn's atmosphere, including the phenomenon often called ring rain, where charged particles and dust linked to the rings follow magnetic field lines down into Saturn's upper atmosphere. And that means the rings and the planet are exchanging material and energy in a way that feels like a slow leak. A reminder that rings are not eternal. They are evolving structures that can slowly drain or spread. Saturn's rings also produce spokes, ghostly radial features seen as dark or bright streaks across the rings, likely tied to electrostatic effects that lift fine dust above the ring plane and let it behave differently, and the fact that a ring made of ice chunks can also host faint, transient electrical phenomena makes the whole system feel like a dream. Frozen, debris behaving like a plasma experiment in sunlight. Even the colors can change subtly across ring regions, mostly bright white ice, but with hints of tan and gray, where particle size distributions differ or where contamination is higher, and those differences tell you the rings are not chemically uniform and not dynamically uniform. They're a patchwork of zones shaped by resonances, collisions, and moon interactions, a set of overlapping stories written in orbital mechanics. If you want a calmer way to hold all of this without getting lost in the labels, think of the rings as music. Saturn's gravity is the steady bass note, the moons are the repeating percussion hits, and the ring particles are the crowd responding, forming waves where the beat repeats, smoothing out where collisions damp motion, building sharper structures where shepherding confines edges. Gaps are not emptiness but reorganized rhythm, places where the repeated tug prevents a stable accumulation, while dense regions are places where accumulation is allowed and then shaped. The Cassini division isn't just a dark stripe. It's a boundary between resonant regimes, and the Encke and Keeler gaps aren't cuts. They're lanes maintained by embedded moons that also make ripples like boat wakes in a thin, icy sea. And all of it remains silent, because in space there's no air to carry sound, so the greatest moving structure you can see in the solar system does its work without noise, with only motion as proof. Imagine drifting above the rings during Saturn's night side, with the planet's shadow cutting across the disk like a dark blade, and beyond the shadow the ring particles catch sunlight and glow, while within the shadow the ice becomes muted, and you can see the rings are not a flat painted band, but a three-dimensional place with slight height variations and ripples. And you can sense that every particle down there is in constant interaction, bumping, sliding, sometimes sticking, briefly, sometimes shattering. Yet the overall shape stays coherent because the orbit is the anchor, and orbit is patient. There's a mental trick Saturn's rings play on you. They look like a solid thing, so your brain wants to treat them like a table or a road, but they are closer to a swarm, and the swarm behaves like a fluid on large scales, even though it's made of solid pieces, a granular disk that can support waves, wakes, and instabilities the way a fluid does. Except the molecules are ice boulders, and the collisions are slow, and the timescale is measured in hours and days and years rather than seconds. Once you accept that, the ring system stops being pretty and becomes hypnotic, because you're watching the laws of motion and gravity exposed without camouflage. On Earth, friction and terrain hide clean physics. In Saturn's rings, the physics is the terrain. And the rings aren't only beautiful because they're bright, they're beautiful because they make the invisible visible. Resonance becomes a wave you can photograph, a moon's pole becomes a gap edge you can trace, a hidden moonlet becomes a propeller scar, an electrical effect becomes a spoke, a slow loss of material becomes ring rain, and the entire disk becomes a record of time and tugging. If you're letting your mind settle, there's something incredibly calming about that kind of order, because it's complexity that resolves into pattern rather than noise. A billion particles behaving like one structure, because each particle follows the same simple rule, fall around Saturn, and all the complicated detail arises naturally from repetition, not from effort. So as you drift into sleep with Saturn in your head, let the rings be your anchor. Bright ice in a thin plain, cut by dark gaps and fine divisions, stirred by moons into waves that wrap around the planet like slow spirals, edges shepherded into sharp lines, tiny embedded moons carving lanes and leaving ripples, clumps forming and dissolving in self-gravity wakes, ghost spokes appearing and fading, the whole disk changing quietly, constantly, but never losing its overall shape. And if you want one final image to carry out of this part into the next, picture Saturn's rings from above as a luminous record spinning silently in space, every groove a wave, every gap a resonance, every sharp edge a moon's repeated touch, all of it moving with the calm certainty of orbit. No rush, no noise, only steady motion, until your thoughts slow down enough to match that same rhythm. Saturn's spin is the spine of the whole planet, because it rotates so fast that it can't hold a perfect sphere and instead bulges at the equator and flattens at the poles, and that shape isn't a cosmetic detail. It's evidence that Saturn is a fluid world responding in real time to rotation and gravity, a planet that behaves more like a rotating ocean than a solid ball. That rapid spin also organizes Saturn's atmosphere into bands and jet streams. And the reason Saturn can look calm is not because its winds are weak, but because haze and softer colors smear the contrast, turning violent motion into something that looks gentle from far away, like watching a storm through frosted glass. The bands you see are streams of air moving at different speeds, and where those streams meet, shear builds, cloud streaks form, eddies roll up, and the atmosphere behaves like a layered conveyor belt wrapped around a planet the size of a small star, except the conveyor belt is made of gas and the motion is driven by both sunlight and internal heat. And Saturn absolutely has internal heat. More energy leaves the planet than it receives from the sun, so it isn't just a passive ball reflecting light, it's a heat engine still leaking warmth from its deep interior. And that deep warmth matters because it's one of the main fuels for convection, the slow vertical boiling of gas that can sit hidden for long periods and then erupt into storms so large they rewrite the planet's appearance. Saturn's cloud decks are stacked by chemistry and pressure, so what looks like a surface is really the uppermost visible layer of a much deeper system. And as you descend, the pressure climbs hard and fast, the temperature rises, and the same hydrogen and helium that feel like a thin sky at the top become dense, warm, and fluid-like below, with cloud layers formed where specific compounds condense. Higher ammonia ice clouds, deeper ammonium hydrosulfide layers, deeper, still water clouds where the most energetic convection can happen, And that matters because the deepest water cloud convection is where Saturn's truly violent storms are likely born, building charge separation and lightning, meaning there are places inside Saturn's atmosphere where electrical storms crackle through alien clouds even if the upper haze keeps the visuals subdued. Saturn's rare planet-encircling storm events, the great white spots, are one of the best examples of hidden energy turning into visible structure, because they can begin as a bright convective eruption, a towering plume that punches upward into higher, colder layers where it becomes extremely bright, then spreads into a broad, turbulent disturbance that can wrap around the planet as the fast zonal winds shear and stretch it, creating a banded scar that persists for months, sometimes longer, and the whole thing is a reminder that Saturn's calm face is a temporary mask, not the truth of the system. In a way, Saturn feels like it stores instability, letting heat and buoyancy build in deep layers until conditions cross a threshold, then releasing it in one massive reorganizing breath. And that release is not random chaos. It is immediately sculpted into pattern by rotation and jets, which is why Saturn can produce storms that are simultaneously violent and elegant, like a huge brushstroke painted by physics across a spinning canvas. Now take that idea, turbulence becoming structure, and look at Saturn's polar regions, because this is where the planet stops feeling like a normal banded gas giant and starts feeling like a rotating fluid lab experiment that accidentally became iconic. The North Polar Hexagon is not a mark on Saturn, it's a jet stream locked into a six-sided path, a standing wave pattern in a fast-moving current where the flow and the wave modes stabilize into a polygon the way vibration can stabilize into a clean note. And the reason it looks impossible is because your brain expects winds to make circles, not straight edges. But in a rotating system with the right shear and wave interactions, the current can hold a repeating geometric shape for years. The hexagon is basically atmosphere doing geometry, and that makes it uniquely hypnotic because it feels like something designed. Yet it's just fluid dynamics taking the shortest stable route through a set of constraints. Inside and around that hexagon region, Saturn can host polar cyclones, massive vortices centered near the poles, so the polar environment becomes layered. A central rotating storm, a surrounding jet stream that locks into a polygonal ring, and then outward from that, the regular banded winds, all of it held together by rotation and the planet's thermal structure, and all of it existing without a solid surface to anchor it. Saturn's polar phenomena also tie into seasons and sunlight, because while Saturn is far, it still has axial tilt, and over its long year, the sun angle shifts, changing which hemisphere is in stronger sunlight and which is in longer shadow, and that slow seasonal forcing can alter temperature gradients, haze production, and cloud visibility, which can make certain features more or less obvious at different times, meaning even when the dynamics are steady, what you see can change because the lighting changes, and Saturn's rings amplify that effect by casting moving shadows on the planet and on themselves, dark bands sliding across the pale atmosphere like a slow clock hand. Those ring shadows can create localized cooling and can change the visual texture of the cloud tops, and when the sun is low, relative to the ring plane, even small vertical variations in ring structure can cast long, thin shadows that reveal texture you'd never notice otherwise. So Saturn becomes a system that literally redraws itself with light, not changing its physics, but changing its appearance as geometry shifts. Go deeper again, and Saturn becomes less about clouds and more about states of matter, because the pressure inside gas giants becomes so immense that hydrogen does things it cannot do on Earth, and at sufficient depth it can become metallic, meaning it conducts electricity like a metal even though it's hydrogen, and that conductive layer is critical for generating a magnetic field through dynamo action, moving conducting fluid creating and sustaining magnetism, and Saturn's magnetic field is unusually aligned and symmetrical compared to many other planets, which is weird in its own right because dynamos often create tilted fields. Saturn's field is so clean that it suggests a dynamo configuration that produces a highly axisymmetric magnetic structure, and even if the details are still debated, the result is clear. Saturn's magnetic environment structures space around it, trapping charged particles, shaping radiation belts, guiding plasma flows, and creating auroras at the poles when energetic. Particles follow field lines down into the upper atmosphere and collide with gas, releasing light. Those auroras are the visible footprint of an invisible machine. And at Saturn, that machine doesn't operate in isolation because the rings and moons feed and interact with the magnetosphere, turning the whole Saturn system into a coupled environment of gravity and electromagnetism. The rings themselves are made largely of water ice particles, and while the big chunks are mostly governed by gravity, smaller dust grains can become electrically charged by sunlight and plasma, meaning electromagnetic forces can subtly influence their motion, and Saturn's magnetosphere can also channel charged ring-related material down into the atmosphere in processes sometimes described as ring rain, material and charged particles connected to the rings traveling along magnetic field lines into Saturn's upper atmosphere. So the planet and rings aren't separate categories, they exchange material and energy like a slow leak and a slow return, and that exchange is part of why Saturn feels alive as a system rather than a static object. Now, one of the most Saturn-specific interior ideas, the one that makes the planet feel like it has weather inside itself, is helium rain, and you don't have to treat it as a fantasy image. It's a physical possibility based on how hydrogen and helium behave under extreme pressure and temperature. In certain deep interior conditions, helium can become less soluble in hydrogen, leading it to separate into droplets that sink deeper, and as those droplets fall, they release gravitational potential energy as heat, adding to Saturn's internal energy output. The phrase helium rain sounds cute until you imagine it properly. Not raindrops falling through air, but dense helium-rich droplets falling through a supercompressed hot fluid environment, deeper and deeper, continuously releasing heat, a slow internal drizzle that could help explain why Saturn radiates more heat than expected for its age. Whether helium rain is the full story or only part of it, the key point is that Saturn is not just cooling passively. It has internal processes that can maintain heat and drive atmospheric dynamics. So the planet's smooth look is a visual trick, not a true lack of energy. Saturn's atmosphere, because it's layered and because the planet rotates quickly, can support multiple types of waves and oscillations: gravity waves, Rossby waves, and other planetary-scale wave patterns that can organize clouds into repeating structures. And these waves can interact with jet streams, sometimes reinforcing stability, sometimes creating instabilities that trigger storms, and the result is that Saturn's weather has a kind of disciplined complexity. The planet can hold steady patterns for long times, then reorganize in dramatic episodes, then settle back, as if the system breathes in slow cycles. Even the differences between Saturn and Jupiter matter here, because Jupiter's atmosphere often shows high contrast turbulence and multiple persistent storms like the Great Red Spot, while Saturn's colors are more blended, with more haze scattering and lower contrast, and Saturn's big storm events are more episodic, which creates a different emotional feel. Jupiter feels like constant visible power. Saturn feels like quiet power that sometimes breaks the surface. But that doesn't mean Saturn is weaker. Its winds can still be extreme, and its storms can still be enormous. It means Saturn's display settings are different, shaped by temperature, haze chemistry, and how heat moves through the atmosphere. Saturn's distance from the Sun and its composition also influence cloud formation and the altitude of different condensates, and because the visible layer is just one slice of a deep system, changes in vertical mixing or haze production can make Saturn appear more or less banded at different times, again, reinforcing the theme that what you see depends on lighting and chemistry as much as on motion. and because Saturn's rings are so dominant, they influence how we emotionally read the planet. The rings create a sense of elegance and stability, but that elegance sits on top of a massive, fast-spinning, heat-leaking world with deep convection, lightning, and storms large enough to circle the globe. And that contrast is Saturn's signature: violence expressed softly, structure emerging from turbulence. You can also think of Saturn's atmosphere as a place where scale distorts intuition. A small cloud feature can be the size of a continent. A band can be a jet stream thousands of kilometers wide. A storm outbreak can release energy on a scale that would be catastrophic on Earth, but becomes a normal planetary process on Saturn. And because it's all gas with no surface, the planet can reshape and recover without leaving permanent scars, which makes Saturn feel like an endless moving painting, always changing but always coherent. And the calmest way to hold all of this is to reduce it to a few linked images that actually match the physics. A pale gold giant spinning fast enough to flatten itself, wrapped in soft bands of wind that hide their speed behind haze. Deep layers where pressure turns gas into dense fluid and possibly metallic hydrogen, powering a dynamo and a magnetic environment that shapes space. Rare convective eruptions that punch upward and bloom into planet-spanning storm scars, complete with lightning in deep clouds. A North Pole where a jet stream locks into a perfect hexagon. A standing wave geometry carved out of wind. Seasons that shift slowly over years, with ring shadows sliding across the atmosphere and changing the planet's look like a slow-moving sundial. And an interior that leaks heat, potentially helped by helium separating and sinking like a deep, invisible rain. Saturn becomes the quiet proof that you can have enormous energy and still look gentle, that you can have chaos and still form geometry, that you can have constant motion and still feel calming because the motion is organized. So if you're listening and letting your mind slow down, take Saturn as a model of disciplined movement. Everything there is moving fast, but the system is stable. Everything is changing, but the patterns persist. Everything is huge, but nothing is rushed, and the planet just keeps turning, smoothing turbulence into bands, locking wind into a hexagon, letting deep heat rise and occasionally erupt, letting magnetism shape invisible space, letting seasons and shadows slide slowly across its face, until your thoughts start doing the same thing Saturn does, spinning down from sharp edges into softer bands, settling into rhythm, and finally quieting into sleep. Saturn gets even more unreal when you stop thinking of it as a planet with rings and moons, and start thinking of it as one connected system where everything is feeding everything else, where the rings aren't just orbiting, they're interacting, where moons aren't just circling, they're sculpting, where space around the planet isn't empty, it's a moving environment full of particles, plasma, dust, and invisible field lines, like Saturn is sitting inside its own giant electric weather. And the reason this matters is because it's the part most people never picture correctly. The Saturn system isn't quiet because nothing happens. It's quiet because the action is mostly frictionless and silent, which makes it perfect for sleep, because you can imagine massive motion without any noise attached to it. Start with the magnetosphere, because that's the invisible architecture. Saturn's magnetic field extends far out into space and creates a bubble where charged particles get trapped and guided, and inside that bubble you have plasma, ionized gas, moving around, being accelerated, being redirected, sometimes driven into the planet's upper atmosphere to produce auroras, sometimes interacting with ring particles and moon-made material. A magnetosphere isn't a thing you can hold like a rock. It's a set of rules that space is forced to follow, like lanes on a highway made of magnetism. Saturn's magnetic field is unusually aligned with its rotation axis, which makes the system feel clean, but clean doesn't mean simple. The rotation of the planet drags the magnetic environment with it, so plasma and charged dust tend to co-rotate to some degree. And then the moons and rings add their own inputs, creating regions where material is added, removed, or reshaped. When you picture Saturn's auroras, don't picture a thin, pretty ribbon like Earth's, and stop there. Picture them as the end point of a circuit. Particles are energized out in space, guided down along magnetic field lines, and slammed into the upper atmosphere near the poles where they glow. It's Saturn showing you where energy is going. And Saturn's rings sit right inside this magnetized environment like a huge, bright, frozen disk that can interact with charged material in subtle ways. Ring particles can become electrically charged by sunlight and plasma, and the smallest dust grains can respond to electromagnetic forces as well as gravity, meaning the rings aren't just a gravitational structure. They're also part of an electrical environment, especially in the fine dust and in the ways material moves between rings and planet. That's where the idea of ring rain comes in. Material linked to the rings, especially small charged particles and dust, can travel along magnetic field lines and fall into Saturn's upper atmosphere, like the rings are slowly sprinkling material downward in a process that's invisible most of the time, but real in its consequences. The rings, in other words, aren't isolated jewelry. They're exchanging material with Saturn, slowly, patiently, over time. And time matters here because it connects to the big haunting question. How long can rings like this last? If ring material is slowly being lost to the planet, and also spreading outward and inward due to collisions and gravitational interactions, then the rings are not eternal. They evolve. They're born. They change. They thin. They get reshaped. Saturn's rings feel permanent to us because we see them in one snapshot of cosmic time. But on long scales, they're a process, not a monument. That isn't sad. It's beautiful in the most Saturn way possible. Beauty that exists because physics allows a temporary structure to become stable for a while, then slowly transform. Now tie that to the moons, because the moons are the hands on the clock that keep tapping the rings into patterns. You already know, moons create gaps and waves through resonances. But the more important vibe is that the moons and rings are engaged in constant negotiation. A moon's gravity pulls on ring particles in repeating beats, creating density waves, bending waves, edge scallops, and sharp boundaries, while ring particles collide, exchange momentum, and damp out chaos. That combination, repeated forcing plus constant collision, makes structure. It's why the rings can carry wave patterns like a record, why edges can stay sharp, why gaps can persist, why narrow ringlets can be shepherded into place. The ring system is not fragile, it's actively maintained by rhythm. And then you have the freak show that is the F ring, the one that refuses to sit still and look clean. The F ring is thin, clumpy, kinked, braided, constantly getting tugged and combed by nearby moons like Prometheus and Pandora, which pull streamers and create knots and strands that form and disperse. If the main rings feel like disciplined lines, the F ring feels like a living rope. It's the ring that proves the system is dynamic, not static. And the best part is that all of that is happening in silence. No sound, just orbit after orbit after orbit, each pass slightly modifying the texture, like a slow sculptor that never stops moving its hands. Now bring Enceladus back in, because Enceladus is Saturn's biggest flex as a system. A small icy moon, bright and clean-looking, with fractures near its south pole that vent plumes of water vapor and ice particles into space. Actual geysers shooting into the vacuum. Those plumes are not just a cool fact. They are a supply line. They feed the E-ring with fresh material. That means one of Saturn's rings is being actively replenished by a moon, right now, in the present tense. That's a direct link between moon geology and ring structure, a pipeline between interior ocean and orbital dust. And if you take that seriously for a second, it changes your whole sense of Saturn's environment. The Saturn system isn't just rings of ancient debris slowly evolving. Parts of it are being refreshed by active processes. Enceladus is likely venting from a subsurface ocean beneath its ice shell, and the fact those plumes exist suggests internal heat and tidal flexing are keeping some region warm enough to stay liquid, with water and dissolved materials being brought close enough to the surface to erupt outward. That eruption turns a hidden ocean into an observable phenomenon, which is one of the most insane science gifts in the solar system. You can taste ocean material without drilling through miles of ice because the moon throws it into space for you. That's why Enceladus is such a big deal. It's not just interesting, it's accessible. It's a place where chemistry and habitability questions can be studied through plume analysis. And when those ice particles drift out and become part of Saturn's E-ring, the system becomes a loop. Internal ocean. Plume, ring, magnetosphere interactions, slow loss, and redistribution. Saturn is recycling. It's a giant gravity basin with active sources. Then Titan sits on the other side of the mood spectrum. Titan isn't feeding rings with plumes the same way. Titan is running an entire atmosphere and surface cycle that feels like an alien cousin of Earth. Thick nitrogen atmosphere, methane weather, hydrocarbon lakes and seas, dunes of organic grains, rivers and channels carved by rainfall that is literally methane and ethane, with water ice acting like bedrock because the temperature is so low. Titan is not a moon, it's a world. And Titan's atmosphere interacts with Saturn's magnetosphere too, because Titan sits inside Saturn's magnetic environment for much of its orbit, meaning it can be bathed in plasma and energetic particles, which can affect chemistry in the upper atmosphere and contribute to the complex organic haze that makes Titan glow orange. Titan is basically a chemistry factory. Enceladus is a geyser. The rings are a disk of ice. Saturn is the heat engine in the center, and the magnetosphere is the invisible frame that ties it all together. That's the core of Part 5. Saturn isn't one object. It's a connected machine. Now, if you want to feel that connection more personally, imagine the Cassini spacecraft. Because Cassini is the reason we understand the Saturn system as a living environment instead of a postcard. Cassini didn't just take pretty pictures, it watched patterns, it tracked changes, it mapped fields, it measured particles, it flew through plumes, it saw ring waves and ring spokes and propeller features and edge ripples. It watched Titan's haze and lakes. It observed seasonal changes over years as Saturn moved through part of its long orbit. Cassini turned Saturn from beautiful into understandable, and even then Saturn kept secrets. Cassini's long mission proved a reality that's easy to forget. The Saturn system changes on timescales you can observe if you stay long enough. Storm outbreaks appear and fade. Ring structures shift. Titan's methane weather produces cloud systems and rainfall events. Seasonal lighting changes the planet's appearance and the behavior of haze. The system is slow, but it's not frozen. Cassini also performed the grand finale, the series of dives between Saturn and the rings, passing through the gap like threading a needle through a moving disk. And those passes were about understanding Saturn's gravity field, ring mass, and internal structure more precisely. Because even if Saturn is a masterpiece visually, the deeper story is always physics. How much mass is in the rings, how the planet's interior is layered, what the magnetic field tells us about the dynamo, how the atmosphere rotates at depth, how internal heat is transported upward. Saturn looks soft, but its answers are hard. And there's one more thing Cassini made. Emotionally obvious. Saturn's rings are not just pretty, they're a time question. Are the rings young? Are they old? Were they formed from a moon that broke apart? Or are they ancient structures continuously refreshed? The brightness of the rings suggests young, because micrometeoroid dust should darken them over time. But brightness can be misleading if collisions and resurfacing keep ice looking fresh, or if the ring mass is large enough that contamination is diluted. Cassini's measurements narrowed some of this down but didn't erase the mystery completely, which is kind of perfect. Saturn gives you beauty, and then it gives you a question you can't finish in one sitting. The rings feel eternal because the pattern is stable, but stability isn't immortality. It just means the structure can persist for a while under the right conditions. That's another calming thought for sleep. Things can be temporary and still be real, and still be beautiful. Saturn's rings don't need to last forever to be worth imagining. Their temporary nature makes them more precious in a cosmic way. Now zoom back in and let the system become a quiet, sensory scene. Picture Saturn's planet light. The sun out there is weaker than on Earth, but the rings reflect sunlight like a bright disk, and that reflected light can softly illuminate the planet's night side in subtle ways, like a pale lamp made of ice. Picture the rings casting thin shadows on Saturn's cloud tops, moving slowly as the sun angle shifts, dark bands sliding across creamy atmosphere. Picture Titan passing through the ring plane in the distance, a hazy orange sphere with a thick atmosphere that filters sunlight into dim copper tones. Picture Enceladus as a tiny bright bead with a spray of ice shimmering behind it, plumes catching sunlight like dust in a beam. Picture the magnetosphere as an invisible shape surrounding them all, guiding charged particles, making auroras flicker at the poles, making Saturn's upper atmosphere glow faintly where energy is dumped. Picture the rings themselves as billions of separate ice chunks, each one orbiting in silence, each one occasionally colliding with a neighbor, grinding down, clumping, being stretched into wakes and waves and ripples that wrap around the planet like grooves on a record. And then picture the moons as sculptors, some embedded in gaps, carving lanes, some outside, pulling resonant beats into the disk, some feeding rings, some clearing rings, some just orbiting as witnesses. Saturn's system is the closest thing we have to visible orbital physics, and it's soothing because it makes complexity readable. On Earth, so much is messy, because friction and terrain and noise hide the clean patterns. At Saturn, the patterns are the landscape. The rings literally show you resonance. The waves literally show you gravity's rhythm. The plumes literally show you interior oceans. Titan's haze literally shows you chemistry and sunlight interacting. The auroras literally show you where particles are flowing. Everything is a sign. Everything is an output of simple rules repeated over time. That's why Saturn can calm your mind. It's a huge, complicated system that still resolves into understandable rhythms. If your thoughts are racing, Saturn's system is a reminder that most things don't need to be forced. You don't need to push ice into a ring. Orbit does it. You don't need to carve a wave into the disk. Resonance does it. You don't need to invent an atmosphere. Chemistry and sunlight build it slowly. You don't need to make a moon active. Tidal flexing can heat it enough to vent. The universe isn't working hard. It's repeating rules, and repetition is soothing. So let Part 5 settle as a single connected idea. Saturn is not a planet with extras, it's a network. Rings exchanging material with the planet, moons sculpting the rings, a moon feeding a ring with ocean spray, a moon running an alien weather cycle under an orange sky, a magnetic field framing the space around everything, auroras marking the flow of energy, and a giant heat-leaking world in the center spinning fast and organizing motion into bands and geometry. No sound, no urgency, just steady, repeating, connected motion. In the next part, we can go fully into Titan or fully into Enceladus. Pick one mood: the hazy methane world with lakes and rain, or the bright icy world with geysers and an ocean underneath. Titan is the Saturn moon that feels like the universe remade Earth's rules and swapped the materials, because everything about it looks familiar in shape but alien in substance, and that's exactly what makes it so easy to sink into mentally. It's a world you can recognize without being able to fully predict. Titan has a thick atmosphere, thicker than Earth's in some ways, made mostly of nitrogen, and from far away it looks like a smooth orange marble because its upper atmosphere is packed with a photochemical haze, a smog of complex organic particles created when sunlight and energetic particles break apart methane and nitrogen high above, and the fragments recombine into heavier molecules. That haze scatters light and hides the surface in visible wavelengths, which means Titan spent decades as a mystery world where you knew something was under there but you couldn't see it, and that alone gives Titan a dreamlike personality, a moon wearing a mask. When spacecraft finally peered through with radar and infrared, the mask didn't reveal a dead ice rock. It revealed a landscape shaped by weather, rivers, lakes, dunes, shorelines, and erosion, just like Earth, except the water is not water. Titan is too cold for liquid water to sit on the surface. Instead, Titan runs a hydrocarbon cycle. Methane and ethane are the working fluids. They evaporate, form clouds, condense, fall as rain, flow in channels, and pool into lakes and seas. That is the core mental flip you have to accept, because once you accept it, everything else makes sense. Water ice at Titan's temperatures behaves like bedrock. The ground is mostly frozen water, but frozen water there is as hard as rock is here. So Titan's methane rain falls onto a surface of ice rock, and the liquid methane acts like water does on Earth, carving channels, cutting valleys, feeding rivers, and shaping shorelines. Picture standing on Titan's surface. You're not stepping on snow. You're stepping on ice that behaves like stone. Above you is a dense sky that filters sunlight into a dim, copper-orange daylight. The sun is far away, smaller in the sky, and the haze turns the whole world into a soft twilight, even at noon. The air is thick enough that wind feels more substantial than it does on Earth, and because Titan's gravity is lower, the atmosphere feels even more supportive. If you had wings, you could almost imagine gliding for an absurdly long time, drifting through orange light over a landscape shaped by liquids that look like fuel. Titan's polar regions are where the liquid lives most obviously. There are real lakes and seas of methane and ethane, especially near the North Pole. Broad, dark patches with smooth surfaces, sometimes with branching inlets and shorelines that look eerily like coastlines on Earth when you squint, except everything is in a colder palette, and the liquid is hydrocarbon. Some of these seas are huge, like inland oceans, and they can have waves, currents, seasonal changes, even evaporation and replenishment patterns driven by Titan's climate. Titan's weather isn't constant everywhere. It's seasonal and regional. Clouds form, storms happen, and then long, quiet periods can follow. Titan's year is tied to Saturn's orbit around the Sun, so its seasons are long, and the distribution of rain and cloud activity can shift over time, meaning Titan is a slow weather machine, not a daily thunderstorm planet. You don't need constant rain to reshape a world. Rare storms can carve long channels and rearrange shorelines, and Titan shows evidence of that. Drainage networks, channel systems, features that look like they were cut by flowing liquid. Titan's dunes are another shock, because they prove wind is a major sculptor too. Around Titan's equator are vast dune fields, long parallel ridges stretching for immense distances, like desert dunes on Earth, but built from different stuff. The grains are likely organic solids, complex carbon-based particles that formed in the atmosphere and fell to the surface like soot over geologic time, then got moved and sorted by wind into dunes. Titan is literally making its own sand out of atmospheric chemistry. That image is insane in a quiet way. The sky manufactures particles, the particles fall, The wind shapes them into ridges, and the ridges become a global-scale pattern. Titan's landscape is the result of two sculptors working together: hydrocarbon rain-carving channels and wind-piling organic grains into dunes. It's Earth's process template running with swapped ingredients. And Titan doesn't stop at surface weather and dunes. The deeper story is that Titan is probably layered. Beneath the crust of water ice, many models suggest Titan has a subsurface ocean of liquid water, possibly mixed with ammonia or salts that help keep it from freezing solid. That means Titan may have two different liquid worlds: an outer world where methane and ethane are liquids cycling through atmosphere and surface, and an inner world where water is liquid in the dark, beneath the ice. The existence of a subsurface ocean matters because it means Titan isn't just a surface chemistry toy. It might have internal reservoirs and slow geophysical processes like cryovolcanism or crustal exchange that could move materials between layers over long time. Even if those exchanges are rare, the mere possibility means Titan is a world with depth, not just a frozen shell. And then there's the chemistry, the thing that makes Titan feel like a prebiotic factory. Titan's atmosphere is nitrogen-rich like Earth's, but the methane adds a carbon source, and sunlight drives reactions that build complex organic molecules. Some of those molecules settle out onto the surface, where liquids can transport them, concentrate them, and deposit them in new places. Titan is constantly generating organics and distributing them across a planet-like landscape. If you care about origins of life chemistry, Titan is one of the most naturally productive labs in the solar system because it runs for free. Sunlight in, complex organics out, plus a stable atmospheric environment and active transport via rain and rivers and lakes. It isn't life, but it's chemistry that looks like the kind of chemistry you'd want to study if you're trying to understand how complexity can arise. And the best part is that Titan does all of this while orbiting Saturn inside a larger system, meaning it isn't isolated from space weather. Titan spends time inside Saturn's magnetosphere, getting bathed in plasma and energetic particles that can influence upper atmosphere chemistry and haze formation. Titan's thick atmosphere also protects the surface from much of that, but the upper layers are constantly being processed, constantly being transformed, constantly being replenished. Titan's haze is not a static coat. It's a living product line. That's why Titan looks the way it does. Not because it's dirty, but because it's active, producing aerosol particles continuously. Now tie Titan back to Saturn's rings and moons in the calmest possible way. Imagine Saturn as the pale gold anchor, rings glowing like a thin, bright disk, and Titan as the distant orange world, moving slowly through that environment like a lantern drifting around a giant. The ring plane cuts across the sky from Titan's perspective as a bright band, and Saturn itself would hang huge in Titan's sky, a bright ringed presence that would make Earth's moon look like nothing. Titan is a moon, but it is not small emotionally. It's a world with its own sky, its own weather, its own seasons, its own geology, and maybe its own hidden ocean. And the reason that's soothing at night is because Titan is familiar enough to hold and alien enough to dissolve your everyday thoughts. It's hard to obsess about your to-do list when you're imagining a coastline of methane, under an orange haze, or dunes of organic grains stretching for hundreds of miles, or rainstorms that aren't water but still carve valleys into ice rock. Titan pulls your brain into a different set of rules, and that shift breaks the loop of normal worries. So keep one clean scene from this part: dim orange daylight filtered through haze, a thick nitrogen sky with methane clouds drifting in slow motion, distant dark seas of liquid hydrocarbons near the poles, long parallel dune fields near the equator, channels cut into ice-hard ground, and far above it all, Saturn hanging in the sky as a pale giant with rings, silently watching. Titan continues its orbit without hurry, running its alien waterless weather cycle again and again, making organics in the sky and moving liquids across the surface, slow and steady, until your thoughts slow down too, and finally let the night take over. Saturn is structured because rotation and gravity force structure into a planet that has no solid surface to hold anything in place. And once you picture that correctly, the whole world stops being a postcard and becomes a machine. It spins fast enough to squash itself wider at the equator and flatter at the poles, and that same fast spin organizes a deep fluid atmosphere into jet stream lanes wrapped around the globe, lanes that can move at extreme speeds even while the planet looks smooth, because haze blurs contrast and makes violent motion look gentle. The surface, you see, is only the uppermost visible cloud deck, a thin slice of a stacked system where different chemicals condense at different pressures and temperatures, higher ammonia clouds, deeper layers with other condensates, deeper still water cloud levels where convection can become powerful enough to generate lightning. So the true Saturn weather isn't just top-layer swirls, it's vertical motion, warm, material rising, and cooler material sinking through huge depths, and sometimes that convection builds quietly until it erupts as a major storm outbreak, a bright convective plume that spreads, gets stretched by winds, and can evolve into a planet-encircling disturbance band, leaving a pale scar that persists for months. Because Saturn's atmosphere is constantly being sheared by jets, any large storm becomes a tug-of-war between upward energy and sideways stretching, which is why Saturn can take one violent eruption and turn it into an elegant, banded structure, turbulence refined into a pattern by rotation. The North Pole is where Saturn's pattern from chaos becomes almost unfairly clean. A persistent hexagon-shaped jet stream that looks drawn with a ruler but is really fluid dynamics locking into a stable rhythm, like a standing wave configuration in a fast-moving current, often accompanied by a polar vortex at the center, creating a layered polar architecture of rotating storm, polygonal jet, and outward banded winds. This is not decoration. This is Saturn's atmosphere finding a stable arrangement under constraints of rotation, shear, and thermal gradients. And the reason it feels hypnotic is because it is geometry made of wind, a shape that should not exist if you only know Earth-scale intuition. Go deeper and Saturn becomes pressure more than weather, because pressure rises rapidly and the gas becomes denser, warmer, and more fluid-like, hydrogen and helium compressing into regimes that don't occur naturally on Earth's surface, and at sufficient depth, hydrogen can become electrically conductive, supporting dynamo action that generates Saturn's magnetic field. Saturn's magnetic field is unusually aligned and symmetric compared to many planets, which makes its geometry feel clean, but the environment it creates is still complex. A magnetosphere filled with trapped charged particles, plasma flows, and interactions that can drive auroras, faint glows near the poles where energetic particles ride magnetic field lines into the upper atmosphere and dump energy as light. That magnetosphere matters because it intersects with Saturn's rings, and the rings are where Saturn turns invisible forces into visible structure. Because the rings are not a solid band, they are billions of mostly water ice particles orbiting in a razor-thin plane, ranging from fine dust to chunks the size of buildings, each particle on its own orbit, constantly colliding, grinding, bouncing, clumping briefly, separating, and the entire disk stays coherent, because gravity is the rule and collisions are the damping. On large scales, the rings behave like a granular fluid. They can support waves, ripples, instabilities, and organized patterns, even though the molecules are ice boulders, and this is why the rings are such a perfect sleep image. They're motion without noise, complexity without franticness, a system where every piece is moving but the overall structure stays stable. Resonances with moons carve much of the ring structure, because repeated gravitational tugs at specific orbital ratios create spiral density waves, ripples in particle concentration that wind around the planet like grooves on a record, and bending waves, vertical ripples that reveal the rings have height and can be slightly lifted and folded, even if that height is tiny compared to their width. The famous Cassini division looks like a clean gap between major rings, but it isn't empty. It's a region of reduced density and altered structure heavily shaped by resonance, and within and around it exist many ringlets and wave patterns that only become obvious when you observe closely. Smaller gaps like the Encke and Keeler gaps are maintained by embedded moons that clear lanes through ring material, and those moons also disturb the edges, creating scalloped ripples and wakes, like a boat passing through a thin icy crowd and leaving. Patterns behind. The rings contain self-gravity wakes, elongated clumps formed because the particle's own gravity lets them gather into streaks, while collisions prevent full collapse. So the rings become a constantly forming and dissolving texture of dense strands and looser regions that changes how light reflects, making the rings appear different depending on viewing angle and sun angle. Hidden moonlets embedded in ring material can create propeller signatures, disturbances that look like tiny propeller-shaped gaps, revealing bodies too small to easily image but large enough to carve a recognizable scar, which means the rings are full of intermediate objects, not quite moons, not quite mere debris, constantly tested by the competing processes of accretion and erosion. The F-ring is the ring that refuses to behave like clean jewelry, a thin, kinked, braided ribbon constantly combed and tugged by nearby shepherd moons, producing streamers, clumps, knots, and strands that appear and disperse, making it feel like a living rope rather than a static line. The rings are not isolated from Saturn either, because fine dust and charged particles can interact with the magnetic environment, and some material can drift along field lines or otherwise migrate into Saturn's upper atmosphere over time, meaning the ring system is evolving, not eternal, and the rings may be slowly losing mass even while they maintain sharp structure through ongoing gravitational shepherding and collision-driven damping. This evolution feeds the big haunting question of ring age and origin, whether the rings are relatively young, perhaps formed from the breakup of an icy moon or captured body that wandered inside Saturn's tidal limits, or older but maintained and resurfaced by ongoing processes, because micrometeoroid dust should darken ice over long time. Yet Saturn's rings are bright, and brightness can point toward youth, but can also be preserved if collisions continually refresh surfaces, or if mass is large enough that contamination is diluted. So Saturn's rings look like certainty and act like a puzzle at the same time. Saturn's moons turn the system into a neighborhood rather than a planet with accessories, because many of those moons are full worlds with their own weather, geology, and energy sources, and the crucial point is that moons and rings are coupled. Moons sculpt rings through resonances and shepherding, moons can feed rings with new material, and moons can interact with Saturn's magnetosphere by adding plasma and dust. Enceladus is the clearest present-tense link in the whole system, a small, bright moon that vents plumes of water vapor and ice grains from fractures near its south pole, likely driven by tidal flexing that generates internal heat, maintaining subsurface liquid water and pushing material out through cracks. Those plumes feed Saturn's E-ring, meaning one of Saturn's rings is actively replenished by a moon right now, turning the system into a loop where orbit causes flexing. Flexing causes heat. Heat maintains liquid water. Liquid water finds fractures. Plumes erupt, particles drift into orbit, and a ring persists as a faint halo. Titan is the other extreme, a moon wrapped in thick orange haze with a nitrogen-rich atmosphere and methane weather, where methane and ethane act like water, evaporating, forming clouds, raining, flowing in channels, and pooling into lakes and seas. while water ice acts like bedrock because the temperature is so low. And Titan's equatorial regions host vast dune fields, likely made of organic grains produced in the atmosphere and sorted by wind, making Titan a chemistry and climate world that feels like Earth's processes running with swapped ingredients. Other moons add strange moods, some ancient and cratered, some fractured, some showing signs of past activity, each one shaped by its orbit, resonances, and history. And the resonances matter not only for rings but for tides, because repeated gravitational forcing can pump orbital energy into heat, which is why some moons remain active instead of freezing into total dormancy. Saturn's seasons add a slow layer of change because Saturn has axial tilt, so over its long-year sunlight shifts north and south, altering temperature gradients, haze production, and cloud visibility, and ring shadows slide across the planet and across the rings depending on sun angle, creating moving bands of darkness that reveal ring texture and change the planet's appearance like a slow clock, while reflected light from the bright rings can subtly illuminate Saturn's night side, creating a gentle planet light effect that ties rings into the planet's lighting environment. Saturn's internal heat is a constant background engine, more energy-leaving than sunlight provides, and one possible contributor is helium, separating from hydrogen at depth and sinking as dense droplets, releasing gravitational energy as heat, a process often described as helium rain, which matters less as a poetic phrase and more as a reminder that Saturn can have internal processes that maintain warmth and drive convection over long time. The biggest calming truth about Saturn is that its enormous motion organized into repeatable patterns, jet streams smoothing turbulence into bands, deep convection occasionally breaking through as massive storms, polar winds locking into a hexagon, magnetic fields shaping invisible space into structured environments, ring particles obeying orbit while collisions damp chaos, resonances carving waves you can literally see, moons sculpting gaps and edges, moons feeding rings with fresh ice, and seasons and shadows shifting slowly across years. Nothing in Saturn's system needs sound to be dramatic, because in vacuum the most immense processes are silent. And that silence makes Saturn unusually soothing to imagine, a pale gold giant turning in the dark, rings, glowing as a thin bright disk, waves and gaps etched by gravity, moons drifting in steady orbits, plumes sparkling briefly in sunlight, auroras faintly flickering at the poles, everything moving without urgency, repeating the same rules until complexity becomes pattern. If you hold Saturn as a mental place, hold it as rhythm rather than trivia. Fast rotation, slow seasons, constant orbits, repeated resonances, endless collisions, deep pressure, quiet internal heat, and a bright, thin ring plane turning gravity into visible order. So your thoughts can do the same thing Saturn's system does. Keep moving, but smooth into wider, calmer bands until the sharp edges fade. Saturn is the cleanest example of how the universe can take something chaotic, countless particles, turbulent winds, invisible fields, and force it into order through repetition, because almost everything in the Saturn system is a loop that runs again and again until it becomes structure. The planet spins, the winds shear, the rings orbit, the particles collide, the moons tug, the magnetosphere circulates plasma, sunlight drives chemistry, internal heat leaks upward, and the same few rules repeat so consistently that the outcome looks like design. Start with the planet itself and picture the soft look correctly as a visual trick, because Saturn's creamy, muted colors don't mean low energy. They mean haze and scattering, fine particles and chemical layers that blur contrast, so the atmosphere can be moving at extreme speeds while still looking smooth from afar, like a storm seen through frosted glass. Saturn's rotation is fast enough to reshape its body, pulling the equator outward and flattening the poles, and that rapid spin is the reason the atmosphere forms banded jet streams, because rotation plus thermal gradients plus fluid turbulence tends to organize into alternating eastward and westward flows, and where those flows meet, shear zones form and clouds get stretched into streaks and lanes. So Saturn's visible bands are not painted lines, but the topmost expression of deep, moving currents. The clouds you see are only a thin upper layer of a stacked system, because as you descend, pressure climbs rapidly, temperature rises, and different compounds condense into clouds at different depths. Ammonia ice high up, deeper condensates below, and still deeper water clouds where the most energetic convection can occur, meaning Saturn's strongest storms likely originate in regions you can't see directly, building buoyant plumes that punch upward until they reach colder layers, where condensates brighten and become visible, and when those plumes break through, the planet can produce eruptions so large they become global-scale disturbances, stretched and wrapped by jets into long-lived bands that can circle the planet. Lightning within some Saturn storms is a key detail because it proves deep water cloud convection can be intense enough to separate charges and discharge electricity, which means Saturn's weather is not just swirling paint. It's a real electrical and thermal engine operating through immense depths. The most surreal Saturn pattern is the North Polar Hexagon, a stable polygonal jet stream that looks impossible until you treat it as a flow pattern stabilized by waves and shear in a rotating fluid. The current circles the pole, but instead of forming a smooth circle, it locks into a six-sided path, because that configuration can persist under the right balance of forcing and damping, and it can sit around a polar vortex like a geometric crown, showing that Saturn can take turbulence and freeze it into shape, without ever needing a solid boundary. Beneath the weather, Saturn becomes a pressure world where hydrogen and helium compress into dense hot states, and at sufficient depth, hydrogen can become electrically conductive, enabling a dynamo that generates Saturn's magnetic field. Saturn's field is unusually aligned and symmetric compared to many planets, which gives its magnetosphere a clean geometry. But clean doesn't mean simple, because the magnetosphere is a moving environment full of trapped charged particles, plasma flows, and energy transport that can drive auroras near the poles when particles ride field lines down into the upper atmosphere and release energy as light. This magnetic environment doesn't exist in isolation because Saturn's rings sit inside it like a huge bright disk of ice embedded in an electrical and particle-rich space, and ring particles, especially small dust grains, can become charged by sunlight and plasma, allowing electromagnetic forces to subtly influence their behavior, which is part of why Saturn's ring system feels like more than gravity alone. Its orbit plus collisions plus resonance plus occasional electrical effects layered on top. The rings themselves are not a smooth sheet, but a swarm. Billions of mostly water ice particles ranging from dust to boulders, each one orbiting Saturn according to the same basic rule, fall around the planet, colliding frequently enough that the system behaves like a granular fluid on large scales, capable of carrying waves, wakes, and sharp edges, even though it's made of discrete objects. Collisions are crucial because they damp random motion and keep the ring from blowing apart, while also grinding particles down and resurfacing them, which can keep ice bright. And gravity is crucial because it keeps every particle in orbit and allows clumping tendencies to appear. One of the most important sculptors of ring structure is resonance with moons because repeated gravitational nudges at specific orbital ratios create spiral density waves, ripples in particle concentration that wind around Saturn like grooves on a record, and bending waves that lift ring material slightly above and below the plane, proving the ring has thickness and can be warped in localized patterns. Large-scale gaps and divisions exist where resonance forcing prevents stable accumulation or reorganizes particle orbits, while narrow gaps are often maintained by embedded moons that clear lanes and simultaneously ruffle the edges, creating scalloped patterns and wake-like disturbances that persist as signatures of the Moon's passage. The rings also host self-gravity wakes, elongated clumps that form because ring particles attract each other into temporary dense strands, while collisions prevent collapse into a solid body, producing a constantly shifting texture that changes how light reflects and makes the rings appear different depending on viewing geometry. Hidden moonlets embedded in the ring can leave propeller disturbances, partial gaps shaped like propellers, revealing bodies too small to easily image but large enough to shove particles aside, which means the ring contains a whole spectrum between dust and moon, objects continuously caught between accreting and being eroded. The F-ring is a thin, restless ribbon that behaves like a braided rope, constantly being tugged and combed by shepherd moons, producing knots, kinks, strands, and streamers that appear and disperse, making it a place where structure is perpetually being created and destroyed by repeated gravitational passes. Ring material is not permanently sealed off from Saturn either, because fine dust and charged particles can migrate, and some material can drift into Saturn's upper atmosphere over time, implying the rings evolve and potentially lose mass. And this ties into the biggest ring puzzle: how old the rings are and how they formed, since the rings are bright yet. Micrometeoroid dust should darken ice over long time, but brightness can be maintained if collisions refresh surfaces or if ring mass is large enough to dilute contamination. So ring appearance is a clue that can be interpreted in multiple ways, depending on your assumptions about recycling and replenishment. Saturn's moons make the system feel like a functioning neighborhood rather than a planet with ornaments, because some moons are active, some are atmospheric, some are ancient and cratered, and their gravity shapes ring edges, gaps, and wave patterns, while their internal processes can add material to the environment. Enceladus is the cleanest present-tense link, a small, bright moon venting plumes of water vapor and ice grains from fractures near its south pole, likely powered by tidal flexing that generates internal heat, maintaining subsurface liquid water and allowing pressure to drive material out through cracks, and those plume particles feed Saturn's E-ring, meaning a moon, is actively replenishing part of a ring right now, turning the Saturn system into a loop where orbit creates flexing. Flexing creates heat. Heat keeps liquid water. Liquid water escapes as plumes. Plumes become ring particles, and ring particles spread into a faint halo. Titan is a different kind of active world. Thick nitrogen atmosphere, methane and ethane cycling as liquids, clouds forming, rain falling, channels carved, lakes and seas pooling, especially near the poles, while organic haze forms in the upper atmosphere as sunlight breaks apart methane and nitrogen and builds complex molecules that settle onto the surface, and equatorial dune fields likely made of organic grains show that winds shape Titan's surface into global patterns. The contrast between Enceladus and Titan is important because it proves Saturn's environment isn't one theme repeated, it's multiple active processes coexisting. A moon feeding ring material from an ocean, a moon running an alien weather, cycle under a haze-filled sky, rings carrying visible resonant waves, and a giant planet driving banded winds and occasional massive storms, all inside a magnetic bubble that structures charged space. Saturn's seasons add another slow layer because axial tilt shifts sunlight over time, changing haze production and temperature gradients, while the rings cast moving shadows on the planet and on themselves depending on sun angle, making the system's lighting change like a slow clock, and bright ring particles can reflect sunlight back onto Saturn's night side in subtle planet light, tying rings into atmospheric illumination. Saturn's internal heat output, more energy leaving than sunlight provides, keeps the planet from being a passive reflector, and one proposed contributor is helium, separating from hydrogen at depth and sinking, releasing gravitational energy as heat, a process often called helium rain, which matters mainly as a reminder that deep interior physics can shape surface weather over time by controlling how heat is transported upward. The simplest way to hold Saturn without getting lost is to treat it as repeating rhythm, fast rotation organizing winds into bands and locking polar flow into a hexagon, deep pressure turning gas into dense fluid states and generating magnetism, internal heat feeding convection that occasionally breaks through as massive storms, rings orbiting as a granular disk where collisions damp chaos and resonances carve waves, moons tugging, shepherding, and sometimes feeding rings with fresh material, seasons and shadows slowly relighting the planet, and everything happening in silence, because vacuum removes the noise and leaves only motion, and motion, when it is predictable and patterned, has a calming effect, because your brain can stop fighting it and start matching it, smoothing its own sharp loops into wider, slower bands, the way Saturn smooths turbulence into structure.